And welcome back to Doing Things Dan's Way. This is part 2 of a 2-part series on doing circuit board layout in Altium Designer 19. So the previous video to this one took us from a napkin drawing all the way to the end of creating and validating a schematic. And at this point, this video starts off with us jumping into importing the netlist from the schematic into the PCB editor side of Altium Designer 19. So what exactly are we designing? Well, from the previous video, we drew up this napkin drawing of a simple dual LDO. So we're taking a USB input and giving ourselves 3.3 volts and 1.8 volt output. So component-wise, we have a micro USB connector, an input bypass cap, the dual LDO, and a couple sets of output capacitors and test points, and finally an output connector. So click up here if you have not seen part 1 and want to see the schematic side of this. Otherwise, hang on here and we will jump right into importing the design into the PCB editor. Here we go. Okay, so now that we have a clean compile, we're going to say design update PCB document, and here's the name of the document it's going to update. When we click that, what happens is it dumps. It's saying, okay, we found differences in the design. Do you want to generate the ECO? We say yes. And this isn't obvious, but down here we want to say execute changes. We can't just say validate changes. And what it does, it makes sure that it has a footprint for all the added parts and all the networks and everything. It hasn't done anything. It's just checked that it actually can do the work. So it can, obviously. I'm going to click execute changes. And close. Okay, so what it did was it pulled all the parts in. Now, what you might notice here kind of quickly is there's no IC. Where'd my IC go? Well, if I go back to my IC and click on it, go back to general for a second, there is no footprint associated with this part. We didn't do that step yet. So we can add it right here, or we can go back to the schematic library. Again, this library is specific to just this one design so far. And I could click on that mini USB, and I could add the footprint right here. I think we're not making anything special about that library, so I'm just going to add it right here. Make it easy. Click add. Okay, putting that in, it found the part, it found the location of it, and now we can see it here. This little model. Okay. Now if we do a project compile, just to make sure, it's an update. So it's going to push the footprint out. And now that there's a pin, we're going to get the pins connected to the appropriate network. Oh, netlist rather. There we go. Look at that, we got our part now. Now what I'm going to do is I'm going to take this schematic, I'm going to drag it to a second screen here. Now if you have multiple monitors, this is much easier to use a second screen, which is why I have 3 screens on my desk, because I normally put the schematic off to one side. And in fact, there's a way where you can highlight multiple parts like this and they show up on this side. I don't currently have that active right now, and I've kind of forgotten where to find that. Let's see if we can find it real quick here. I found it. Tools, Preferences. Go into System, Navigation. Down here is Cross Select Mode. If you want to turn this on. And there's some options, we'll leave them on default for now. Press OK. So look what happens now if I click on J1 on this side, J1 over here will highlight. The great thing is now I can come in and I can say, okay, let's say J1, TP1, and C1, C2 are all associated with one block. They're highlighted over here. So now I can grab, press and hold, and grab that block of parts. So this is huge. I can take, okay, now I can take TP2 and the 2 bypass caps that go with it. On this side, I can come over here, I can highlight them and move them aside. So now, even though they can be all interspersed, and this could be 50 parts, you know, I can grab this whole block out of, let's say, a much bigger schematic and drag this whole block off to the side, do a little mini layout of the parts, and then drag it back into my PCB. So you can see how powerful this is. So even if I just take, let's say, the IC and the bypass caps that go around it, okay, that represents this block, or this grouping here. So yeah, this really is helpful. So I'm going to take my output here, my input, and just start kind of just blocking these out. Oops. Just roughing these in. I'm going to take the IC and the input caps for a second. And this bypass cap, just take those 4 parts and drag those into here. And then, again, the same rule applies. I can left drag and just barely touch parts to highlight them, or I can right drag and have to go all the way around them to select them. So slide these over, bring C7 in. Now I'm going to, again, this is right clicking and dragging to move, and then the wheel and the mouse to zoom in. So I can zoom in here and see, okay, so pin 1 here is my actual input. 5 and 4 are not high power connections. So come all the way in. Here's my 5 and 4. These are actually not where I want VN to come into. VN needs to come into pin 1, and ground is pin 2. See it here? So what I'm going to do is take this, I'm going to click and hold my left mouse button and spacebar to rotate. And now I have the option of placing this. Now the same story applies. If I press G, I get grids, and now I can identify what grid I want to move the parts around on. I can do a very large grid and the part will jump around more. Or I can do a really small one. Now here what I want is the 2 bypass caps to physically be between the connector and the part. So I'm spread these out a little bit, and I do C2. The order is really not that important, it's an LDO. Feed bus and ground, so it's between 1 and 2 that are critical. And over here on the connector, V bus and ground. So this will lay out nicely, this will lay out nicely straight across. And you can see in our models you have this this barrier here. If I press L for layers, bring up the layer manager, and that's called a guard, this guard layer. Top or bottom, it all shows up as green. They just didn't choose to make it a top layer thing at all, so this doesn't do anything really over here. But turning this on and off will turn off those guards that you saw. So let me get the second cap in here. C2, this is a bigger guy. So as long as I don't overlap these guards by more than, they can be on top of each other, they shouldn't overlap. If I actually do this sort of thing, they'll be too close together and it'll be hard to get, the pick and place won't be able to grab the 2 sides of this part without touching this part. So you want them no more than like this, and perhaps even better, have a little bit more gap. We'll deal with the designators in a minute. Again, right clicking to drag. C7 needs to be right next to pin 3. So 1, 2, 3 is right there. So I'm going to do this. So now ground is going to be here. If this is more of a high-speed layout, I can have V-bus kind of come up and over. This goes, oh, I'm sorry. This needs to come down. So ground can go over the top to get to this guy. This is the power pad for ground, and this is the power input ground. Here's my bypass, which will also go to ground. Now V-bus will get V-bus. We'll get that guy over there somehow. These are just pull-ups for the enables. No big deal there. And then here's my V out. Let's grab bypass caps. So here's one. Sure, I don't get TP3. Okay. Where'd TP2 go? Okay. I'm going to shift click to disconnect this part from the listing or from the selection. Or I can just click and drag a group, slide them over. TP1 actually belongs on the VN. That's V-bus. These two are going to be the other output. And that's for that guy. Let's get this out of the way. What I'm going to do is just do a little bit of a placement. In fact, maybe I'll do this. Now what happens when you do a layout like this is you realize, oh, okay, I actually need a ground. So I realize there's a lack of symmetry in my overall design because I'll be able to do something nice like this, but I don't have a ground connection down here. So I can very quickly just come back to here and come to my highest numbered one, TP3, or maybe, you know what I'll do? I'm going to change this one to be a ground. So I'm going to rotate him, call him TP3, and then shift drag, and I'll call this guy TP4 now. I didn't have to redesignate. These jumps are too big, so I'm going to, while I'm still holding my mouse button and dragging, I'm going to press the G key, and down here, see this grid 100? If you look at that for a second, while I move this, if I press G, it's going to adjust to a new grid. So that let me put that designator a little more appropriately. Sometimes you just can't get where you want to be without going to an even smaller grid, so I'll toggle to a smaller grid and just make it look pretty. Okay. I'm happy with all that. Now here I just say, now I made some changes to the schematic, I'm going to say project, well I can do a project compile just to make sure I don't have any errors. And messages didn't pop up with any errors, which is good. Now I can say design, update the PCB. We just keep iterating through this process. Execute the changes. You can see it added a test point. It removed test point 3 from that one net and added the test points to the appropriate nets now. And we added a new test point. It showed up down here, which is now, that's our V out 2. And TP3 is our ground. So I'm going to come over here, line him up. I'm going to stick this guy here. Okay. And let's get these outputs somewhere close. So C5 and okay, so you can see how eventually we're going to have V out 1, V out 2, and there's no ground right next to these. The ground will have to come in from here. So let's just kind of park these right on the outputs for now. And you can see how the rat's nests move, and you can make them look nice. Okay, so we have a basic layout. Grab all this and scooch it a little closer. I'm not worried about the size of the circuit board at all at this point. We've got lots more to do before we worry about that. Let's go ahead and do a little bit of designator cleanup. So I'm going to grab J1 here. Now if you find that you're selecting things you don't expect to, if you click the layer that you're trying to move, it will be the first thing that gets selected. So if it's on top of this pad, for example, if I click this guy, first thing it should grab is the yellow. If it's not sure, you can just continue to click and it'll cycle through the different things that it sees. Okay, so in this case I'm going to rotate these guys. Because they're close enough together that I think rotating them would make them look a little nicer. And again, you can zoom way in and do this cleanly. J1, J1. These guys I'm going to rotate. And of course, all the properties are available here. So if I double click on it, this window is going to open. I can change the text height and the stroke width, the thickness of each stroke, the type of just look for the parts. That's all available to you. And I'm just scrolling with the mouse and right click and dragging to now let's say we want to change a parameter. I'm going to open this one all the way up for a second. Let's say we want to change all of these test points to have a different stroke and different size. I can click all of them, go to properties. Let me just lock this for a moment. Oops. Okay, let's close that panel. Properties. Okay. So since I have them all selected, it's going to come up and show me each one of the values that's common to what I've selected. So since I selected text, these are all the text parameters that are common. So very quickly I can come up here and change these to 50 mil high, and I can thicken them up a bit so they're a little more bold and obvious. Okay, and so now those are a little more readable. They kind of stand out. They're the things that a user is actually going to be looking for when they're working on this design. Just going to work on the symmetry a little bit here. Just going to click and drag to create a line down the center of the connectors just to see what's happening. Okay. That's looking pretty good. Now let's say, okay, I wanted this guy to be bold as well. If I click on the one I want to copy, shift, click on U1, and come back to properties. I locked you. Okay. Now notice the text height is an asterisk because I have multiple text heights or stroke widths selected. If I click on it, it's going to pop up and show me what the very first one I selected is. And so I can just do this. Well, you click on it, press enter. Click on it, press enter, and then it updates all of them to the parameter that's there. So it's kind of a copy of a parameter. So if I wanted to go, with these C2 was my master, shift, click on U1. Now you see I'll drop back to that 40 mil and that 5 mil, which I don't want to do. So we're just going to click out of it. So what I've done is kind of de-emphasize the capacitors and emphasize the test points. Now, this is 2D mode. Everything we've done has been in what we call 2D. If I press the number 3 on the keypad or on the keyboard here, it's going to pull up the 3D models, and I can right-click again and drag around. And the controls here are basically just that right-click. Right-click lets me drag. If I hold Shift, it pulls up this little menu. So if I stay outside of this little menu, I can just drag around. If I hold on a particular axis, then the only thing it does is rotate in that one axis. See, going up and down doesn't change anything. So if you just want to be real specific about rotating one axis, that's one way to do it. If I click on these little bars, then I get into this rotate mode, which I find really, really annoying for the most part. Because sometimes I just accidentally grab that. But clicking right in the middle does the same thing as clicking anywhere else. So you can just wobble it around. Now a couple shortcuts here. If I do a Control F, right where my cursor is, it's going to flip right around that point. So I can flip right around this connector. Control F. That's super helpful. Again, zooming in and out with the scroll on the mouse is nice. Other whiz-bang cool things you can do. You can actually fly inside the board. So you just keep zooming. Oh, well, make me a liar. You used to be able to fly inside the board. Huh, they took that feature away. How weird is that? Okay. Maybe it's just not enabled, but yeah, you can fly inside and actually look at all the vias and a multi-layer board, all the traces and planes from the inside out. Kind of cool. So pressing L brings up the layers menu. And so if I go to view options, for example, I can turn on and off the 3D objects. Well, I can go with 3D mode on and off. I can turn off the 3D bodies. So this lets us just look at the pads, which is kind of cool. You can also change, layer styles and layer color patterns. You can set full configurations in here. Well, that's not what I want to do. Let's go back to 3D blue, which is great. And then, yeah. So, very cool. I really like it. And depending on your graphics processor, this can be really slow or really, really fast. Wish I could see the... Okay. Let's go back and press the number 2, go back to 2D mode. 2D mode. Okay, let's go ahead and draw some traces. So currently, if we want to look at the layer stack, this is a 2-layer board. So if we go Design, Layer Stack Manager, this pulls up the manager that lets us identify all the layers of the board, the number of layers, the thickness of the board, of the layers, impedance of the board, all kinds of fun parameters. Just going to pull up to show you that I have it set up for a 2-layer board. And again, see, it pulled up a properties window, and I'm just going to drag that into this left here. So here we have a top overlay, a solder mask layer, a top signal layer that's indicated as 1 ounce copper, a core, a bottom layer, bottom solder, bottom overlay. So we can add layers to this. But that's just to show you. It's already set up for a 2-layer board. What that'll let us do, if I go press L for layer, now I can see all the layers that are possible. So you can see the top and bottom copper layers that are available. So I'm going to turn on the bottom layer now. And these are all the individual layers for the top and the bottom. So everything's turned on at the moment. If we turn off all the mechanical layers all at once, and all the other layers, you see a lot of stuff kind of disappears from this. I can even turn off the guards. And assembly, we can get ourselves all the way down to, let's turn this all off. You can really get down to just this real simple routing capability. So to route, I'm going to again do a P for place, and I do T for track, place track. Now these icons are also up here. You can learn that way too. And now it's in an inferred mode, so let's see what happens. So I'm going to come in here to this V bus, click, and start dragging, and you can see the size of the trace and the behavior of the trace. You can see it doesn't want me to route a V bus trace around anything but V bus. So it's going to jump around a lot, which you don't normally just do this. You can. In fact, that particular route may not be too bad, except it's going to bury these. We'll never be able to get to those again. So what I tend to do is just go point to point and click. This trace is a little bit fatter than that trace, so give me a chance to change that. I press tab. As always, I get the properties tab and I get the pause button. So right now immediately when I press tab, it comes up and adjusts the width. So I'm going to drop the width to 16, and that gets me a little bit closer to the size of the pad. And now that I'm out here, I could tab again and go back to a 20. So you can see how easy that is. And I can go 20 from here to here. And then the bus is there, and I don't want to go 20 right into that. That's probably not a good idea. So I'm going to drop to a 12. Yeah, that's good enough. And then now that I'm out here, I can go back to a 20. Right click to get out of that mode, and then I can go back to right click holding to move things. So same thing here. Do a 16. Now I'll have a poor ground plane, so I'm not going to worry about having the appropriately width traces for this bottom area. This could be something really small, like an 8mm trace. It's just a signal. Okay. Let's keep going on the routing here. Again, I tend to start doing everything on topside routing, so I don't tab 20 mils. Of course, grounds are going to pour a ground plane, so these are not all that critical, but I like to route them anyway. Here, I don't want to be that thick, so I'm going to drop just tab, type 12 mils. Yeah, that's doable. You can see it's just a little bit bigger than the pad, but no big deal. Kind of weird. No, tab 12. What I could do is say, come here, go to this point. Actually, maybe I'll just come this direction. Click on it and drag it back a bit. Now what I can do is if I hold shift, I can highlight these sections and then come back over to our parameter and notice that the parameter that's common to all of these is the width. So I can change that to a 20 and bulk up all the traces. Then come back to here, Control T, and draw that smaller trace right there. So again, I can just bulk these all up. Other ways to select a net, you can do S for select, and you can say select an entire net, or connected copper, or physical connection. So connected copper is anything that's copper at all is going to get selected that's touching this node. So all of this has been touched. Let's see, now this includes pads, includes vias, so I can't change the size of the via or the size of a trace because I have too many different things uniquely identified. So layer is really the only thing that's even kind of common. Now if I come up here to component filters, this is where I can come in and say, I'll drop this down, I can say just turn off all objects, and I can just say now tracks, for example, and now I can come in and I can say, okay, I want to change the width of all of them to 20 mils, and they all bulk up to 20. Or I could, if I had vias on here, or I have pads on here, for example, I could turn off everything, just the pad, and I can change parameters that are specific to the pads. So you get the idea there. When you're done, if you don't go back to all objects, next time you go to select something, you'll be confused because you'll select it and it won't show up in properties. Okay. So, what I'm missing at this point is, okay, there's an option here that's not turned on right now. I like it when I put my cursor over a trace for it to highlight the trace. So I go Tools, Preferences, and I think this is under Board Insight Display. This live highlighting is enabled, but live highlighting is only enabled when the Shift key is pressed down. I prefer to have it always live. So instead of pressing Shift, as soon as I hover over a net, you can see how the nets light up. I really prefer this functionality. So I can see, right away what my options are. Okay, now this trace needs to, you can see right away just by hovering, I need to get this trace up here. So I'm just going to say, I'm going to highlight, or I'm going to start a trace, and then press the plus or minus key on the keypad. It drops the, look down here for a second, see the top layer and bottom layer that are highlighted? If I press plus and minus, I'm walking between those different layers. You can also see that pressing 1 or 2 down here is kind of the hotkey. Let's see if I say, click here, say I'm drawing on the top layer in red. I press the number 2, I switch to a bottom layer. Oops, let's go 2. Okay, come on. Okay, I press the plus key to change to the bottom layer. Bring this over, plus again, brings me back to there. So I've connected that node. Now, let's connect these. And do these with pretty small traces. Tab 8 mil. Oh, see, okay, this exposed pad right here is not connected to a net. Let's go back to our schematic. Okay, so when we built this part, we did not give an exposed pad connection. So, come back to our demo board, we have pads here. This is pad number 9, and that's really the exposed pad. So what we need to do is go back to here and add a pin called EP, exposed pad, and connect it to ground, and connect it to pin 9, because pin 9 is what the footprint has, this pad here. So what we'll do is we'll go back to the schematic. Actually, we'll go back to the schematic library for our part. We'll click on our LDO, and because that's a ground connection, let's just make it easy and we'll put it right here. I'm going to place pin, and press tab to come over here to hit properties. Well, it gave me, this is properties for the whole thing. Okay, there we go. Properties for just this pin. Designator is 9. The name, we'll call it EP, exposed pad. And we'll call it a power pad. Okay. Let's stick that right there. And then we're going to say Tools, Update Schematics. Very good. And now if we go back to our schematic, we should see an extra pin there, which I'm just going to tie to ground. So now schematically we've updated it. Now let's just do a design update PCB. We're seeing that we're adding U1 pin 9 to ground. We're going to execute the change. And it's done. And now look, now we have ground tied to that pad, and when I hover over it, you can see how it's highlighting the net. Place track, T. Tie that to that guy. Okay, so now my plan is to have a pour on the bottom side for ground. So I'm going to go say place via, and so I'm going to go ahead and just place a few vias next to a couple of these critical nodes. There's a ground over here, there's a ground down here. Well, there will be. I don't have it yet. Place via. Now if I press tab right now, it'll come over here and let me change all the parameters. So this is a 12 mil hole and 24 mil diameter via, and there's design rules that affect all this, which I won't get into at the moment, except to say if you load my standard design rules, you will get all this as part of it. Okay, so we have ground vias here, there's vias under our LDO. Now this is an LDO, so I guess you could say it'd be nice to spread the heat around more. So I'm going to place a fill. So PF, I'm going to place a fill, and let's just kind of stretch it out kind of long here. And you can see where I'm going to run into violations. And perhaps there's better ways of doing a couple of these things. Maybe I'll just back off here. You can see how close I can get before I get a violation. Okay, and then I could do a place fill here. If you don't have any violations, it's kind of obvious which net it's supposed to connect to. So you can just pour a nice big pour out here to spread the heat around. What I could do is just say place via, and we could put an array of vias in here to stitch this. So I'm just kind of lopsided there. Get those to line up. Okay. Now here's kind of a neat trick. If I want to duplicate this over, I can highlight the one that I want to copy. Let's say this case, Control C, and it's asking me, and it says down here in the bottom left, select a reference point. If I select the reference point as this via here, and get it to, it's seeing that yellow layer behind. There, it's finally in the center. So if I was to turn the yellow layer off, this would be easier. Now, okay, so I create a reference point to this copied object. If I do a Control V, you can see my reference point is right where it was. So now I can hop to this guy and align with him, and now these spacings are identical. So if I do the same thing here, well, let me just copy these three, Control C, and I'll just leave the reference point out here. There's nothing to get in the way for it to jump to. And now I can just come up nice and clean, copy to there. But if I want to duplicate that spacing, again I can press Control C and copy the spacing. And if I do a Control V, you can see now I'm doing that. But these are all symmetrical, so spacebar, or I could just say mirror on the on the y-axis. Let's see, I'm pressing Y, does that, and I can highlight that guy. So you can see pretty quickly here I can make an array of vias that's going to give me a thermal connection. I can sneak one more in there. These are all on the same power plane, so you just ignore the violations while you do this, and eventually they go away. Okay, we have nicely stitched that to the bottom layer. I'm going to go ahead and just shrink this down a bit. And this is kind of overkill, I get it, for an LDO, but anyway. Now let's see. Before we do any ground planes, let's do these last couple ones just for fun. Let's connect these together. A little bigger. Let's do 16. Any other rat's nests? Okay, all of these are needing to be connected together, so I'm just going to run around here and tie these all together. Okay, and then this guy needs to go here. Okay, I think except for now, all the test points around the edges need to be tied. You know, I really want, it's possible someone would power this from the test points, so I want to fatten those up. Let's call that 16 mils. So that cut and paste can also work in this application. So if I press Control C and copy right there, I can do a Control V, and you can see what I get. I get a trace with no net associated with it. You can see if I highlight it, there's no net on this trace. Control V again, and I'm going to do a Y-axis rotate and connect it to there. And then you can actually see the lack of symmetry, you know, above and below this. But you can see how you can actually take even a trace and copy it over. And then it was smart enough to reconnect it to ground because it saw the ground was on both of these. So I'm just going to grab and clean that up a little bit. Now, obviously I don't need to do that because the ground's right next to me. I can just do this. Over here, again, tab 20 mils. Enter. Okay, I'm seeing one rat's nest right there. Yeah, until I do a ground plane, there's no connection between these points. No big deal. Okay, let's go ahead, and before I do any ground plane, let me go ahead and clean up the borders of this design. So we press L for layers and go back and turn on our fab layer and our board layer. Board is our perimeter. And also there is on this USB connection, there's some information here that says PCB Edge, and it kind of shows you right where the PCB Edge is supposed to be. And that is because if I press 3, okay, what you can see here is that there is, the edge of that circuit board should be right, you know, right where the edge of that connector should be. And here you can actually see inside the board. Now that we have some vias in there, you can actually fly inside the circuit board and actually look around. You can see the traces happening. Okay, so anyway, we have to get this connector needs to be the right distance away from the edge of the board. So pressing 2, come back to here. You can see where in the footprint it has this PCB Edge statement. So I'm just going to line that guy up with what the tool says I should use. And shrink this in a bit. Now I would actually like to have some text on the top to say what this thing is. So I'm going to put that down first. If I get too excited here. P, and place a string S, and press tab, and now I have all the parameters here. So I want this to show up on the top overlay. I want to say this is a MIC see what that looks like. Looks pretty good. I could go ahead and change, you know, parameters here. I can make it a little bit bigger, a little bit thicker, whatever I want. And of course a different font. Okay. Now they have that place. Can come here. And shrink that up as well. Okay, so pressing 3 again. Well, I can't see anything. Okay, let's show you this. Okay, to change the size or the shape of a board, what we do is we just shift click and highlight whatever it is that we're creating the edge with, and it needs to be a closed surface. Once we have a closed surface, we're going to say design board shape, define from selected objects. So I've selected these 4 sides, and as soon as I click that, guess what? It takes and it resizes the board. So if I press 3 for 3D view, I now have a board that's the shape I left. Now, classic. Okay, here's a classic mistake here. My connector is facing the wrong way. See that? Okay, well that's kind of silly, right? Everything else looks pretty good. For the moment anyway, I'll probably change some of these. Give myself a little more spacing, more like that. A couple designators, but otherwise, oops, this looks pretty simple. This is what's so annoying. I wish the rotate wasn't even an option, quite honestly. Could just gotta fuss with it to get it back to normal looking. Okay, so let's flip that around. Now, I can flip it around by literally rotating this connector, but you can see I really want this V out to go straight to this point. So much easier to just reverse the pin order 1 through 4 and call it 1 through 4 this way. So if I go back to my schematic, so I really want pin 4 to be my output number 1. So I'm going to take this and drag it back and use the, let me undo, my grid has changed, I left it at 10 on accident. G, okay, now we're at grid 100, that's better. Okay, so now while I'm holding this, I can press the Y button to flip on the Y axis. I can also do a rotate, well, and then do an X for an X axis. You get the idea. So what I've basically done is just simply reverse the pin order. And now I'll just need to update this, design, update PCB. So it's going to have to change the nets on pin 1 and 4. Execute the changes, close. Okay, now it's complaining, of course, because the part needs to be rotated. So I'm going to take it and spacebar, drop it back in place. Spacebar, adjust J2. Okay, now if I press 3, 3D view, now I can see I've got my connector facing the right way. A little better there. And we are really darn close to being done. Let's press 2 and then do a couple cleanup things. This guy's not particularly centered. These designators are a little bit close. You can see they were touching the guard band, which is kind of nice to have these guards. Let's center U1 here. Let's see, are these tented? Yes, they are. You can see these vias all are tented vias. I can show you the difference here. If a via is not tented, let me click on one and scroll down here to, well, let me scroll. So this is an issue where the resolution of my monitor is, what is it, 1024 by 768 or 1920? It's 1920 by 1080. More vertical resolution is helpful because sometimes Altium does a poor job of, there's more here. Let me tear this off. See down here there was another whole section called test point. Now maybe if I collapsed one of these other ones I could have gotten to it. Let me try that. I'm going to redock it over here and collapse. Okay, well I'm seeing it now. So if I have a via highlighted and that's test point. there's a whole nother category down here that's not showing up. It's kind of a glitch. So let me tear it off again. Properties. Oh, no it's not. Excuse me, where is the... There's a parameter called tenting I'm looking for. It looks kind of just like this. Oh, it's right there. What am I doing? Okay, edit that out. I was looking, I didn't see this the whole time for some reason, so. So if we go to tenting, we turn the tenting off, and then go back to press 3, you can see how the tenting, the solder mask will not be there. Which on a VIA, it really is no big deal. You can probe, makes it nicer to probe. On an array like this, for better or for worse, it's not there. Let's say because this is a heatsink, you didn't want to have the solder mask on here at all. You wanted this exposed so it could like radiate better. You actually can just place a solder mask keep out. And that's as simple as just placing a fill on the solder mask layer, because anything on the solder mask layer is a negative. So I can press L for layers, turn on my top solder mask, and now I have top solder as an option down here. So you can see anywhere where the solder mask is showing is a spot that it's going to not have solder mask. So now I can do a place fill, PF, and I can actually highlight this block like so. And then if I do 3D mode, you'll see that it did not solder mask that area. So if you want an exposed area, that's a very simple way to get it. I'm going to undo that because I don't actually want to do that. And I'm going to turn the tenting back on this VIA. And for example, you can highlight the whole board if you want to do all the tents on all of the VIAs after the fact. And I can just come back here and just filter and just select VIAs and come down and turn the tents off and then back on again, and that's a way of forcing it to apply the tent to all layers. It's maybe a better way, I don't know how to do it, but that's what I found. You just go to each one, turn it on and off again, and then when you go back to 3D mode, you'll see that all of your VIAs are now properly tented. And I tend to do that at the very end of a project, because at some point along the lines I'll place a VIA that didn't have the tent already pre-assigned to it, for example. Okay, so we have a board. Let's do a design rule check. So we go Tools, Design Rule Check, and it's going to pull up a whole set of rules that it wants to validate against. I'm just going to click Run Design Rule Check, and we'll see what we get here. Okay. So what we get is this really nice report. It says that we currently have 24 violations to our design. So as close as we thought we were, we still are not quite there. So I have 3 unrouted nets. I have 7 solder mask slivers, and I have 2 silk to silk clearance and 12 net antennas. So the net antennas are the same issue. We don't have ground plane. I'm going to press 2. So what I have a bunch of VIAs. Oops. I have all these VIAs to the bottom layer, but I haven't drawn a ground plane. So these are actually antennas. They're stubs in a sense. In the same way these VIAs are stubs. They're not going anywhere. There's no other connection on the back side. So it'd be kind of like drawing a trace like this and just leaving it out there. That would also flag as a net antenna. So what I need to do is draw that ground plane. So let's go in, we're going to say place P, and here we're going to say it's a polygon. a polygon pour. So I'm going to say polygon pour. And now it's going to start asking me for coordinates. So I'm going to press tab first. And here we get to do all the parameters. So I'm going to tie it to the ground plane. The ground net, sorry, it's not a plane. Ground net. And I'm going to put this on the bottom layer. Bottom copper. And then these defaults, it's going to be a solid region as opposed to a hatch. It's going to pour over all the same net objects. And if you set to remove dead copper, if you have any areas that are just only one connection, it'll delete the area. So it'll help you see areas that don't have any connection actually. Okay, so I'm going to undo the pause. And I'm going to set a grid to something a little chunkier so it's a little easier to kind of click around on. Yeah, it's a little too chunky. Okay, click there, shoot across, up there. Just gonna draw the four corners, make sure it's square. On this last one I can just right click to finish the pour. And now we have a nice pour. Now if we want to, we can come in and we can grab midpoints and slide things around. We can re-pour the area, we can redraw the nodes. So now if I do a 3D view and I'm not sure why it's jumping like that. If I press Control F and flip it, it doesn't really show me. I can't really see. The solder mask is so solid I can't really see traces, and I can see the traces here. I can't really see them on the backside too well. And that's because if I press L for layers, oops, L, view options, this transparency. So I can adjust how transparent is the solder mask. So here I'm looking right through the solder mask. Here it's somewhere between. You can see the vias that are built into the footprint of that component don't have a tinted vias on them. We wouldn't want that on the top, of course. The bottom here, we actually kind of want that to be tinted, so I'll show you how to do that too. Okay, Control F to flip it back over. 2D mode. Okay, now let's do the DRC again. Tools, Design Rule Check. I'm just going to rerun it. And this will clear all of the faults and then re-establish it. Okay. Let's close this. That XML, I've had some weird issues with the DRC report coming up improperly. Run this again. There we go. Okay, now we're down to 9 violations. We have no unrouted nets because those ground nodes are now actually tied together by the bottom ground plane or polygon pour. So we still have some solder mask slivers and 2 silk to silk issues. So I click on that and then click on the silk to silk complaint. It's going to zoom in and show me, oh yeah, look at that, right there. That's so close it would just bleed together. So I'm going to bump it out. And that actually makes me want to even change my my board outline because of it. And the solder mask sliver, let's go to that real quick. Let's take a look at one here. So yeah, see, it's finding the solder mask between the pads on this footprint it's not happy with. Well, you know what, quite honestly, I can't do much about that. That's just going to be the way it is. So either I ignore the DRC rule check or I change the rule. So quite honestly, I'm not that worried about it. See, this one's even smaller than the others. Okay, the trace between the pads on that part. So I'm fine with all those errors. If you're If you don't want to see errors in your output report like this that you don't want to live with, you can actually change the rules. I'm going to rerun this to make sure the soak to silk goes away. Demo board, tools, design rule check, run. There we go. Okay, so our soak to silk issues are gone, and oh no, there's still one, and the solder mask sliver is still at 7. Let's see, where's this one? Oh, this is our This is our dot. This is our pin 1 indicator. So if we want to change something like that, I'm going to turn off the top and bottom layers just to make it easier to see. Turn off the guard. Okay, so what we want to do is just move this dot out of the way. So I can't... Oh, make me a liar. Okay, why is that part not... See, I set a rule and now it's biting me because I can't see everything. There we go. Interesting. So somehow this dot is a separate object from the rest of the component, which is kind of nice. But let's say I wanted to change just this yellow line. See, I can't click on it because the part, it's one of the primitives of this part. So if I click on the primitive lock here, this kind of explodes or allows me to now go in and literally edit every line or every individual pad of a part. Well, can't edit a pad if I don't have the top and bottom layers turned on. Let's come back to here. See, now I can actually edit an individual piece, like this little plane or this individual via inside the part. So actually we want to do that. We want to turn on the tenting on the bottom. See, I double clicked, now it's letting me pick all the different things that are underneath where I clicked. So let's edit the via. The tenting's not on the top, obviously, because that's going to be where solder is, but I want to turn the tent on the bottom. Right, so now if I look at this in 3D mode, the top one, pressing 3, I need to turn off, so L for layers, view options, I'm going to turn off the 3D bodies. Okay, so the top layer I can see I still have my ground plane with 2 vias in it. If I press Control F, I have to click back over here, Control F. Now you can see the top via has a bottom side tent over it. Solder mask is tenting, but the bottom one does not yet. So if I press 2 and select that bottom via, and turn the tenting on the bottom layer over here, and then click back over here, 3 for 3D view, and there we go. Those 2 vias are now tented. And then a quick check to make sure everything else is as we expect. Control F to flip it. Double check that our tenting is still valid on our part here. Everything else looks good except that hanging off the side part. So before I leave this U1 part, I'm going to turn back on primitive lock so I don't, if I try and drag this part, I'll end up actually dragging one trace or doing something silly like that. So I don't want to be able to click and drag this part separate from its individual components, right? So Control Z. Okay. And then, by the way, you can physically lock anything. In this case, I've just locked this IC. So if I come back, you notice now by clicking here, I'm not highlighting the part anymore. It kind of like hides the part from me unless I double click. Or I get really intense about it. I can finally get it to click. But in general, that lets you... Are the primitives locked? Let's see. Yeah, primitives are locked. It just keeps you from like dragging apart because you've locked its position. So, especially if you're working underneath a part for some reason, and you're constantly accidentally moving the part, or even the whole plane, locking things down really is really helpful. I'll have to research this though, because in this case, this dot was allowed to be a separate piece from the rest of the part, and that somehow was built into the way the component was was built from scratch, so I'll have to learn that trick. Okay, one last time, let's get rid of this guy and this guy and run the DRC one more time. Tools, design rule check. Let's run it. Okay, now all we have are the solder mask slivers, and I'm not concerned about those. I will show you real quick how to get rid of those if you want to. We go to Design Rules, and that's a manufacturing issue. So there is a minimum solder mask sliver rule here, set to 3 mils. So we can just change this to a number like 1 mil. We could go into the rule itself, this enable flag, and we could just turn it off so it doesn't check this at all. That's one way of dealing with it. So if I do that and then I rerun the DRC, we should get an absolutely clean DRC. There we go. So now we have a design it's past DRC. Sometimes just to make sure, I'll go back to the original schematic here and recompile it just to make sure there's no errors that pop up or warnings. So we have no errors or warnings. If I say update the PCB, it should say no differences found. And when I'm in the PCB, when I run a DRC, I get a clean DRC. So the only thing I want to change at this point is this one little silk screen issue over here. I'm going to drag the edge of the board out a little bit, and then I'm going to re-highlight. So I'm shift and clicking to highlight the 4 corners. Design, board shape, define from selected objects. Okay, so all I've done is just stretch the board out. Now a little bit of cleanup. On my fab layer here, I do have some dimensions that were previously drawn. I can show you real quick how to do those. So you say place PD dimension, and then L linear. And then all you're going to do, let's say I want to do the difference between this node here and the next one down. For example, click there, and you can see now I'm able to place it where I want. If I press spacebar, it changes to the difference in the y-axis. You can see I'm 0.32 millimeters out of whack between these two. So spacebar, click on it. Now it picked the board layer because that's the layer I had selected when I started this. If I started with the fab layer highlighted, I would have gotten a dimension like these. Of course, I can always double click on it and I can change the layer and change that to a fab. I want that on the fab layer. So anyway, that's simple. Okay, so now that we have a board, let me hit L for layers, turn everything back on again, turn it off and back on, and that kind of re-highlights everything. Turn on all the layers, make sure everything's enabled. I want everything on so that I can look at this whole drawing. See, now I have 3 different size holes in this design. There's only 10 holes. This all looks good. File name isn't available until we generate gerbers. All the layer names are all stacked up, and those will only happen as we do a print layer. Okay, so let's do the next step, which is to fabricate a board. So this is where we're actually going to generate gerber files and to place them into a zip file that we could submit to a design house. So to do this, we're going to go to our project, and we're going to go to our output job files. So in here I have a standard layout that I use. So I have a PDF. So these are containers, and a container is basically either a group of files or a single file that's built when we click go. So these are all the available file types, from schematics and fab prints and different views and reports like a bill of material or a pick and place output or the Gerber output. So over here I have a PDF output container, and if I click generate on this, it will generate a PDF, and these are the page numbers of the PDF. So you can just add and subtract. So you have to click on these in the order that you want. So page 1 is going to be the schematic, and that could be multiple pages. But the first set of pages will be the schematic. 2 will be a 3D print of the board. This I like to have as a kind of a view of the board from an angle, so you get that three-dimensional view of what the board looks like. And then the next 2 pages are a top and a bottom view in 3D mode. The next page after that will be a PCB print, so it's like a fab drawing. And then finally the last page is an itemized bill of material. So to do this, it's not going to know exactly where on that whole schematic my board actually is. So what I need to do is go back into my board for a moment. I need to go into 3D view. I need to pick the first view to be exactly what I want it to look like. So L for layers. I want to turn on my parts, show 3D bodies on, and I want to give it a little bit of an angle to kind of show some dimensionality to it. I'd like to be able to see inside the micro USB a bit. I'm not sure how easily I can do that and not have it be too radical. Yeah, it's kind of hard to see inside that micro. So I think I'm just going to give it a little tilt, a little angle, kind of recenter it. Okay, now I'm going to go back to that output file and right click on this PCB 3D print and say configure. From here I get to pick the resolution of kind of the print screen. You can see what it started with. It would not be particularly useful. And I'm going to say a custom view and take the current camera position. And I also say take the current view configuration, and that lets you do things like the color of the board, for example, would not be what you selected without this. So press OK. Now let's go in there to do a top and a bottom view. So I'm just going to kind of re-square this up. Okay, just get a nice, simple, straight down top view. Come back to there. Right click on top, configure, take current camera position, take for current view configuration. Okay. Oops. Now here I'm just going to press Control F to flip it with my cursor in the center. See, it's just that simple. Go back to demo board, to the bottom view, right click to configure, enter DPI, current camera position, current view configuration. You can see what just changed right now. You can see the transparency. It actually went lighter than it was a minute ago. Okay, and then PCB prints, if we right click on that one, this lets us select which layers are going to be in the stack up. So right now there's a lot of layers selected, probably more than we really need, but we'll leave it for the moment. And the bill of materials, if you were to configure this one away from what I currently have configured, this is where you pick which columns show up in your layout, the order of the columns, as well as the width of a column, for example. So there's some playing around with this you can do. You can also tell it to export an Excel file and tell it to add that Excel file to the project. And even click Open Export if every time you click on this you want it to open up Excel with this file available. So at the moment I'm going to say, double check this guy. So this is a standard folder structure it's going to stick it into and the file name. So I'm going to just click Generate Content. Depending on how complex the board is, this can take a fair bit of time. It has to pull in all the information and filter it. It has to create all the 3D views. the beauty is you end up with a really, really nice PDF. In fact, you can generate a version of the PDF that has 3D views of the board, which lets the person actually flip and rotate the board around. Okay, page 1's our schematic. Honestly, looking at this right now, this looks a little high on the page. I'd rather have it centered a little more. Okay, page 2, that looks good. Kind of want to get rid of this junk over in the corner there. Page 3, looks good. Page 4, that's simple enough. Page 5, so we can see here's our, oops. So then on this, you can see we have a lot of layers turned on, but you can see the outline of all the parts. You can see the bottom and top copper. It's good to read the notes over here. Make sure this lines up with what you're really going to do, because if you submit the file with, green solder mask and here it says blue high gloss, you will have your project put on hold. And then you can see all the layers are stacked up here, so maybe you want to clean this up. Honestly, I don't really care that much for simple prototype work. We have the backside, the text in the mirror image version of the title block is turned on, which we could turn off. And then here's our bill of material. There's not a lot of parts on this. And you can see it's combined all of these 0.1 caps in one stack on the designator list. And obviously it looks like we need to expand this a little bit to allow it to see more. So I'm just going to close this out. And let's go do a little bit of cleanup. So the demo board, I'm going to grab the schematic, drag it down a little bit more towards the center. Okay, that's fine. And the PCB, press 2. Get rid of some of these. You know what, let's just for fun drag these over here, put them on the back. Now if I press L, it flips layers. So by just clicking L just now, it flipped these two symbols to the backside. So you see there a dull yellow, which is a backside solder mask, or silkscreen layer. This stuff we can just get rid of. Just drag this down here. Okay, and then back to our report. We wanted to change in the PCB print, turn off the title block. Not sure which layer that is, honestly. So let's go back to here for a moment. Let's see, what is that? This inverted text here. What layer is this? Oh, bottom assembly. Okay. So we don't want the bottom assembly layer turned on. Assembly bottom. So we're just going to right click on that and delete them. Yes. Okay. That'll make that look a little nicer. And now what we can do is we can just, I haven't done a save all in a while, let's do that. I'm going to click on generate content, and this will overwrite the PDF file we've already created. Give it a second to finish that save operation. It's asking, do we want to overwrite the file, the PDF file? I'll say yes. Okay, so that looks a little more centered. Down here, these look the same as before, except I have the source screen on the back now. That's nice. And then here, don't have the extra random backside notes. This all looks good. And, oh, we didn't expand this designator field. Let's do that. And maybe the margins could just be shrunk back. Maybe that would help. So we can just go into the bill of materials, configure. Looks like we designated here. Use some more space. Okay. Say okay to that. I'll generate that one last time. Now if you go into folder structure, this is a different kind of container. In this case, we're generating files. So this will generate the Gerber files and the NC drill files. Yeah, this is already a standard setup thing. It will output all the files, it'll output all the layers that we've selected. And if we were to do a multi-layer, a 4-layer board, more layers would be available here. All the parameters for drill drawing and the size of the film, everything, it's all here. I just use all the defaults. It seems to work very generically. And here I'll just say click content or generate content. And just like that, we've got ourselves the NC drill file and the Gerber file. And I'll show you where those show up here in a minute. And that's all we really have to do. I'm going to regenerate this content. And let me show you in the file manager where this all ended up. Turn to LDO. So here are all the files in the Altium structure. So we have that out job, PCB, the project PCB. The structure file gets generated every time if there's not one already. And the XML is that output report. So if we go into project outputs, the logs and the history and the previews, you can ignore all that. If we go into project outputs, here where we have folders where our PDF was built, the design rule check exports happen, so it saves a copy for you. And then we have our NC drill and our Gerber files here. So when I'm ready to actually generate Gerbers, I highlight these two, right click and send to a zip file. And call this, okay, Mike 310 Gerbers. And I never give Gerbers along with like the PDF file because that literally gives them everything they need to build the file. The Gerbers themselves are literally just graphics files. It helps them build the board, but they have no idea what parts go on the board. So these two folders are very generic and they will know what to do with them. So this is all you need to upload. So at this point, we are done with everything we need to submit the files to a design house, and we can have these boards back in less than a week. So let me show you how to go to a website of a design house and actually submit the files. I use PCBWay.com. I found them to be very, very quick, the quality very high, and the price is ridiculously cheap. So we go to PCBWay.com and log in. Now I can give you a referral link if you ask for that, and that will give you a $5 credit on PCBWay. And since the boards tend to cost 50 cents to $1, that's a pretty significant jump on your first set of boards. So here what we're going to do is we're going to say online quote. So these are all the steps in the fabrication, and this is pretty amazing. If we look at a completed project here, so let's take a board that I've done in the past. It's the production process. You can literally see, you get a timestamp of every step in the process, from engineering all the way to package ready for delivery. And so as your board's being built, you get to see literally which step of the process it's in and the timestamps of when it completed each project. This is an amazing level of detail inside the inner workings of this company. So let's go up here and just start the process. This, obviously I pulled up, had been confirmed received. And you can even go a step further and share a design with the community that uses PCBWay, and other people can buy one of your boards. So if you want to do open source stuff, that's how to do it. So let's go online quote, and we are going to put in information about our board. So we're going to this is a single board. There's only one board in a panel, and they do, in my opinion, penalize you if you put multiple individual boards in one space and break them apart yourself. It's actually cheaper to just submit several different designs as separate Gerbers and then let them cut them out and manufacture for them. They don't. It's actually cheaper to do individual submissions, and all of the submissions will be put under one shipping order. So the shipping is actually more expensive than the board very often. So we have one panel. The size, let's go back to our, actually we should be able to go to our fab print here and zoom in. So this is 26 by 24.5 millimeters. So 26, 24.5. Let's pick 10 boards. I tend to see the price being identical up to about 20. Okay, 10 boards, 2 layers, standard FR4. Whatever this is, I'll leave it on standard. I'll leave the thickness as standard. This is standard 60 mil thick board. 6 mil 6 trace is a good gap in trace width minimums to work with that don't penalize you or cost more. The minimum hole size, if you leave it at 0.3 millimeters, that's about right. Let's see, what is I'm using 12 mil holes. What does a 12 mil hole look like in millimeters? So here we can say it's a 12 mil hole. Now if I press Q, it changes all of look in the bottom left corner here, it changes between inches and millimeters. So now if I click on that same via, my hole size is 0.305 millimeters. So that 12 mil hole is a sweet spot where it doesn't cost you any more to use this. If I go to smaller size holes, you can see you can go down to a very small hole, like a 6 mil hole, but the cost of the board goes way up. I can show you that. I like using blue solder mask for demo boards with white silk screen, and they don't charge you anything extra to pick any color you want, which is remarkable. Hot air surface leveling with lead, you can say lead free if you want to as well. Let's leave it as the default, and I always click yes here. Okay, if they want to gold plate it, no big deal. Tinted vias, we have tinted vias, yes. Finished copper is just 1 ounce, no big deal. And if I come up here and I click on calculate, you can see my 10 boards only cost $5. These are 50 cents a board. Now see if I go to 20 pieces. Okay, so now we've gone to 80 cents a board. Interesting. If I say 5 pieces, I'm still at $5. So you can actually play with this. 15 pieces, okay. So if I stick with 10 pieces, I can get them for 50 cents a piece. If I change to, let's say, a smaller size via hole, notice the price goes way up. Now they are $5 a piece. So you can kind of play around with this a bit and understand defaults. Maybe that's the up arrow represents right there as a standard. So, okay, I'll get this out of the way. You can see right now my PCB costs us $5. The more board designs you do, you start getting these discounts. So I have 3% off as a discount. And my shipping is $17. So my total for this entire board set is $21 for these boards. So I can add this to my cart. Now, something else to point out, you can get an SMD stencil. And these are either like a little 4" by 4" stencil or a full framework one. So a full framework design, as you can see here, where's the price? The stencil is $15 for a full metal framework stencil. Or if you do the non-framework, those are only $10. So you get this nice little thing. So for $5 more, you get the full frame. But unless you're putting it in a fixture, that full frame is actually way too big. It's annoying, actually. These small little guys are perfect. You can literally tape them down and just manually screen on the parts. So if you're doing little DFN parts and you're using hot air, this is a great way to go. So now we're only at $37 for 10 boards, including a stencil. And we can add assembly service on top of that. And you can go through this whole thing, a turnkey or kitted and assigned, and they have to go back and quote the total for you, of course. So I haven't done that service myself. So all we're going to do is say add to cart. And now they do want you to use PayPal, and with PayPal you can use a credit card or a company credit card, but they don't take credit cards directly, which I honestly kind of like that fact. But what we're going to do now is we're going to add our Gerber file. I'll do those. Project outputs, Gerbers. Okay. So we upload our file, and we say submit, and then it's going to give us a review. So we submit the order. After about 20 minutes, if they're working, they will review the file and make it available to purchase. At that moment, then you will submit your payment information, and basically that will get you to final approval of your design. So that's kind of as simple as it is. So that's doing things Dan's way, and that's how I lay out circuit boards. Now, this wasn't a complex board. It wasn't 4 layers or more. It wasn't high density, but you get the basic idea of the different steps of the process, you know, and it's just not that ridiculously hard. So I hope this was helpful. If you want to see more content like this, hit subscribe below. Really appreciate you subscribing. And the next time a video like this comes out, you'll get it on your feed. And of course, there's some other videos here that you can take a look at of other content that I've created. So until next time, be blessed.